All right. Hi, everyone. My name is Alex Antonison, and I'm the organizer for Nashville Data Nerds. Thank you for coming online with all of us tonight to be with Mahesh Rao while he leads a conversation with identifying food deserts in Davidson County with Python. Tonight's sponsor is Antonison Consulting Group, which is my consulting company. We help organizations grow efficiently. We help organizations grow through providing efficient solutions. Some associated organizations I'd like to call out are Nashville Software School and Penny University. Nashville Software School, if you're looking to upskill yourself in technology field like software development or data, definitely check them out. Penny University is a great group if you're looking to connect with like-minded folks who are just interested in learning. Real quick, just some housekeeping. While Data Nerds is usually more conversational in nature, that's a little hard to facilitate via Zoom. So the way this works is we'll have our conversation leaders speak for about 30 minutes. But feel free to post questions to the chat. I'll be moderating those questions. And when there's like a logical pause, I'll pause Mahesh and we'll ask a question. And then the last bit is really meant for that kind of group conversation around the topic. Without further ado, I'm going to kick it over to Mahesh.
All right. Thanks, Alex. Can everyone see? All right. I see Heather nodding. Very good. All right. So thanks, everyone, for coming today. I'm going to talk about a project that I've worked on for a little bit. Some of you may have heard this before, but looking at identifying possible food deserts in Davidson County. So a little bit about me. Before I got where I am now, I actually got my PhD in biological sciences from Vanderbilt. I studied retinal regeneration in zebrafish. So that is a entirely separate conversation, but I love talking about it. So feel free to ask me about it at some point. While I was doing some work with biomedical research, I got interested in data. I took the data science boot camp at Nashville Software School and then moved over to work as a data scientist at a small ed tech startup called Amira Learning. And so what Amira Learning is aiming to do is to build a AI reading tutor for kids to practice reading or take assessments with reading. And so I was working with them to develop their machine learning models for detecting when kids uttered an error when they were reading. Couldn't stay away from NSS, and so I eventually went back there to as an instructor for the full-time data analytics program, and then somewhat recently moved over to the program manager for our analytics and data science programs at NSS. If you want to follow along with this, I've added a few new files to the GitHub repo that has this. Also, there is a Kaggle kernel. This has a lot more information, but it's also a lot more descriptive about the individual steps. And so if you're curious about some of the pieces that maybe I don't spend a ton of time covering, you can check that out as well. For the notebook, if you want to start that up, just letting you know, there are some packages that you might need to install. So if you want to, take the time to sort out your environment, please feel free to do that. Otherwise, the slides I'm going through are there, and the code for the notebook is up there as well. So why don't I actually drop these links in the
Already got
chat
it.
so you can you already got it. Wonderful. Thank you, Alex. See, dream team right there. All right, once this loads up, there we go. So why food deserts? This is, hopefully a topic that people have heard about, maybe to differing degrees, but I thought about food deserts in kind of a few different dimensions that really led me to this project. I was having a really just kind of a random conversation with a friend of a friend at one point, and he was interested in food deserts. He was working for a nonprofit at the time, I think, involved with studying food deserts. And what he said that was interesting was how close to home food deserts are. There are food deserts in Nashville, and that really was shocking to me. I'm like, there's grocery stores all over the place. Surely this Nashville can't have food deserts, or they must be really small. And then, so that really kind of piqued my interest and really stuck with me to learn a little bit more about food deserts. And at the time, I had already gone through the boot camp, so I was thinking, surely we can analyze this with a little bit more data. Also, an interesting article that I read, and it's actually not a one-off topic, it's something that's been revisited a number of times, is how there are certain stores that sometimes lead to food deserts. And so I promise this is not a dig against Dollar General. Dollar General is a wonderful store and employer in Nashville, but one thing that this article was positing was that dollar stores like Dollar General might sometimes contribute to the existence of food deserts by kind of creating competition for sources of fresh food. And so we'll talk in a little bit about what a food desert actually is, but that's something that was intriguing to me. And I realized through both of these things happening in relatively quick succession that I didn't really know what a food desert was. And so I needed to learn about food deserts. And then I got interested to explore them more with data and how maybe we can identify whether or not food deserts actually do exist in Davidson County. So what is a food desert? Food desert is defined, has a definition made by the USDA. There's a number of characteristics that are involved with a food desert. But there are things that all of the different kinds of analyses or definitions take into consideration. The first is access to healthy food. So these are sources of fresh food, fresh fruits and vegetables. And the way that they measure access is distance to and or number of stores within a reasonable distance, within a reasonable area. They look at some individual accessibility factors, so family income or vehicle availability. They also look at more community indicators or neighborhood indicators. And so this is the average income or maybe median income of a neighborhood and the existence of public transportation in an area. So the bottom line is looking at low income and low access to healthy foods. So those are the two factors that are typically considered for food deserts, and that's what I'll look at here as well. And this is a link to the actual USDA website where they talk in much greater detail about food deserts. So more specifically, how can you identify a food desert? A food desert is defined at the level of a census tract. So a census tract is a defined area that's normalized by population. And so what that means is that when you have areas that are more population dense, the census tracts will be a little bit smaller. Areas where the population is a little bit more spread out, census tracts end up being quite a bit larger. But it's an area where there's approximately the same number of people in a tract. And so within a census tract, one of the key factors is looking at the poverty rate in the census tract. And so for the analysis that I did here, I used one of the cutoffs that the USDA used of a poverty rate of 20% or greater. So that's the low income part of a food desert. Another factor that they look at is measures of distance to a supermarket. And so there's 3 different ways that they look at that. I followed only one of those. And so the part in bold is that at least 33% of the population is greater than 1 mile from the nearest supermarket, supercenter, large grocery store, basically source of fresh food for an urban area, or greater than 10 miles in a rural area. So there's a little bit of a differentiation between urban census tracts and rural census tracts. But this is a way that the USDA has defined low access. So low income, poverty rate is greater than 20%, and low access is more than 1 mile from a source of fresh food for urban census tracts, or 10 miles for rural census tracts. And so making this a little bit more specific, the things that we need for the analysis are first information about the census tracts, where on the map are they located so that we can overlay other geospatial information, income information for the census tracts, defining if a census tract is urban or rural, and then the location of, I put here farmers markets. I didn't actually include it in this analysis, but that's one of the considerations that you can include, but the location of farmers markets and supermarkets. And so by combining these different factors, we'll be able to identify where food deserts might actually exist in Davidson County. And so with that, I will jump over to the notebook. And so again, feel free to open this up and follow along. Let me make this a little bit bigger. So for those of you not familiar, this is a Jupyter notebook. This is a way that you can write code and see the output. So I'll be going through the code that I used for calculating whether or not food deserts exist in the Davidson County. So starting with reading in some of the libraries and reiterating a little bit about the things that we need. So our criteria are looking for census tracts that have a poverty level of greater than or equal to 20%. And then for the census tracts, at least 33% of the census tract is greater than 1 mile from a source of fresh food for urban areas or 10 miles for rural areas. And so let's get into it. Start reading in the information that we need. So the first thing that I wanted to do was find the census tracts. And so a lot of this analysis is kind of by necessity geospatial in nature. And so I had to find essentially outlines of all the census tracts in Davidson County. This link here actually takes you to a place where you can download all the census tracts for Tennessee. I've subsetted it down from there. And what we can do here is read in the information. And when we look at the data frame, we can see there's a number of kind of location information, some geospatial information. This is the name, the way that the census tract is identified, which is kind of just a series of numbers, some other markers, and this here is the geospatial information. So I won't get into the details of the different nuances of geospatial data, but all of these points are polygons, basically specifying a region on a map or on the globe where these census tracts occur or where they're found. And if we want to visualize what these census tracts look like, we can do a .boundary.plot, increasing the figure size here to make it a little bit easier to see what the actual census tracts look like. And if we run this, we can see overall, this is the shape of Davidson County. All these lines in here are defining the different census tracts. And so as you get closer to downtown, the census tracts get smaller because the population density increases. Whereas in the more rural parts of Davidson County, those census tracts are a little bit larger, again, to account for those differences in the spread of population. Just as a kind of a little bit of foresight for the analysis, I found that the just outline of Davidson County overall is somewhat useful. So this is just reading in that geospatial file. That's just the outline of Davidson County. And so we'll use this a little bit later, incorporate into some of the plots that we make. So that was easy. First thing off the list, checked off. We have our census tracts. Now we can start layering on information to that. And we'll start with the poverty information. Information about poverty is most easily obtained from the census. We just had a census, but the data for that won't be available still for a little bit yet. And if you've worked at census data at all before, you know that it is quite cumbersome to deal with. Luckily, there is a census reporter website. And so this is a really useful website that kind of makes it easy to parse through all the census information. And so I went there, snagged some information about poverty levels in Davidson County, all the census tracts in there. And this is from the 2018 census update. And so if we read this data in, sorry, what we can see is that again, there's some geo identifications, a name for the census tracts or for the geographical region that's being referenced here, total, which represents the total population in the area, and then starting to break down into different groups, the number of individuals that fell below the poverty level in the last 12 months. So this is the total number of individuals in the particular region that fell below the poverty level in the last 12 months, and then breaking it down by males, males under 5 years, so on and so forth. There's a number of different kinds of demographic breakdowns of the data here. We are not going to parse the data that finely. We can just stick with the totals that we have here to work with and calculate our different pieces of information for poverty levels. And so these pieces right here are just dropping the columns that we don't need, using just a list comprehension in Python to only keep the columns that we care about, getting rid of everything else. And then another thing is that the first 3 rows here are some aggregations. So the US overall, Tennessee, Davidson County, and then it's getting into individual census tracts. And so getting rid of those first 3 rows and just sticking with the census tract level, since that's what we're interested in. Once we've cleaned up the data frame, then we can calculate the percent that are below the poverty line in a particular census tract. And so what we'll do is just a simple calculation. So the total individuals that were found to be below the poverty line in the last 12 months divided by the total population, that'll give us the rate, poverty rate for each census tract. And so we'll save that to a new column here. And what we see is that we have this new column here. And you can see for the census tracts, the first 5 census tracts that we're looking at, none of them had greater than 20% poverty level, which is, again, that cutoff that we're looking for food deserts. But again, this is only the first 5 rows, and we can see we can start to break down a little bit more which census tracts actually do have more than 20% poverty rate. So we'll first want to combine this with our geospatial data frame, our geo data frame up here. So we'll need to line that up with this name column. So first thing is just using a little bit of string logic to extract just the census tract numbers, saving that into a new column called name, and then using that column to merge with the Davidson census tracts. And so when we run that, whoops, key error, that's always good. Name, oh, I don't think I actually ran this. There we go. If there are null values, I'm just filling it in with the median just as a stopgap. And now we're able to calculate the census tracts that actually fit that threshold, that have greater than 20% poverty levels in Davidson County. So with that, we have our new column here. We can see for this first row, this one actually is above that level of 20% poverty level that we had outlined previously. And if we again put that on our map and adding a little bit of color, in this case, what we've done is colored each census tract based on whether or not it falls below, or I guess above, that 20% poverty level. So the ones in gray, those are the ones that have greater than 20% poverty level, whereas the ones in red here, those have below 20% poverty. And so already the picture is starting to emerge about where potential food deserts might occur. So we see up here in North Nashville, up here towards Goodlettsville, these are all possible food deserts. But again, we're only halfway there. We only have our poverty level consideration. The next consideration, and one that is arguably a little bit more challenging to get the data for, is access to sources of fresh food. So that will be next up for the analysis here. I'll summarize this text right here. All this is saying is that it actually is surprisingly difficult to find lists of grocery stores or other sources of fresh food. And so what I turned to was one of the Google Maps API endpoints. So Google Maps obviously has a ton of data about a bunch of different stores all over the world. And so what I would be focusing on is sources of fresh food in Davidson County, and using this API as a way to find where those sources of fresh food are located. A few other considerations about where to look is whether a census tract is urban or rural. So I'll need to differentiate that. And then also a little bit of consideration about how far out and actually around Davidson County to look. If you think about if someone lives at the edge of Davidson County, the nearest grocery store might actually be outside of Davidson County. So I want to make sure I factor that in when looking for sources of fresh food. So expanding that search area around Davidson County, actually 10 miles for those rural census tracts. And based on limitations of the API, I actually needed to divide up the search area into a grid and just do a bunch of smaller searches in order to accommodate, again, the limitations of what is returned from the API. So let's start with the first part. Considering whether or not a census tract is urban or rural, Davidson County has actually made it easy for us. They've defined a urban services district, and so we can use that to differentiate whether or not a census tract is urban or rural. So we can read in this urban services district. And so a pretty simple geodata frame here, but this first row is what we care about. And so if we take this geospatial object and again, add that as a new layer to our map, we can see here that the urban services district is this shaded region that obviously encompasses all of central part of Davidson County, Nashville, and extends down towards the Antioch area. It overlaps pretty well, but not 100% with a lot of the census tracts. And so the census tracts that are on the edge, we need to still differentiate whether or not they're urban or rural. And so the decision that I made was if at least 50% of the census tract was inside this urban services district, I called that an urban district, an urban census tract. Otherwise, it was a rural census tract. And so the code here is to calculate that and see whether or not it's an urban census tract. So with geospatial objects in Python, it actually is quite easy to subtract two areas from each other and get the difference in area, as well as divide two areas and get a ratio of one area to another. And so that's what this area is doing, basically saying how much of a particular census tract is inside the urban services area. And of that overlapping part, how much is that compared to the entire area? So again, another ratio, and asking the question, is that ratio greater than 0.5? If so, call it an urban census tract. Otherwise, call it a rural census tract. So defining this function, and then I am applying the function to the Davidson, or the census tract data frame that I have, and adding the values to a new column is rural to see whether or not the census tract is rural. So we can see here we have one rural census tract, a few that are urban, one that's rural here, again, another one that's urban. And so we have this distinction now, and that will be useful in the future when we kind of look to see which grocery stores are close to or within a census tract. Again, because of that differentiation between 1 mile versus 10 miles distance for urban versus rural census tracts. So again, that distinction of urban versus rural. The next part is to search for grocery stores or sources of fresh food around Davidson County. So this will get into a little bit of kind of geometry conversions, but I'll try and simplify it here. In addition to geometry conversions, it's basically just geometry conversions here. For creating the search area, I wanted to go 10 miles around Davidson County to account for stores that might be, at the limit 10 miles outside of Davidson County, but are still available sources of food for rural census tract residents. And so to do that, I used this buffer method for GeoPandas. The buffer method, you would supply it a number of I think a number of degrees of, or a number of miles out of degrees of latitude a number of degrees of latitude out of the number of miles. And so there needed to be a little bit of conversion there. The USGS, though, gave us a handy conversion where we can use this 1 mile equals 0.01449, et cetera, degrees of latitude. And so in order to add that 10-mile buffer around the Davidson County, we can just use this conversion of the equivalent number of degrees of latitude, add that around Davidson County, and that will be our entire search area for looking to look for where sources of fresh food are. With that, I created that that search area, and what I'm going to do is actually go through this next part a little bit quick, just because I see I'm a little bit short on time. But essentially what this code is going to do is, it'll show up here in a second, is essentially make a grid within Davidson County. This little bubble here is because there's a tiny little island that's a part of Davidson County. And so when you're doing 10 miles around a little island, it looks like a giant little blob. But yeah, we have our grid inside Davidson County. And essentially we need to make a search area around each of these points and search within each of those areas for sources of fresh food. Again, going through all this rigmarole because of the limitations of the API. Again, I think I can skip over this and show you what it will look like. But for each of these points, we have a search radius on each of them. And so I'm not going to actually send anything up to the API because this took a few days to run. But essentially what I did was search across each of these points for different kinds of stores that I've listed out here. So I look for bakeries, convenience stores, or what Google calls convenience stores, department stores, so on and so forth, just kind of casting a wide net. I just wanted to get anything that could be a source of fresh food to make sure I was missing as few things as possible. But yeah, so this is kind of the search that I did for all of these points across Davidson County, looking for sources of fresh food. I'm going to skip over this also because this won't run. This is just kind of an example of the code that I used. If you're curious about it, please feel free to look at the code. But I mentioned that without an API key, this code won't run. But like any good cooking show, I ran it and have an already made data frame that we can look at here. So read this in. I actually saved it as a shape file, so another geospatial object. And so this is actually the location of a bunch of different kinds of stores. And if we look at this, it doesn't really have, it's not as clean as we want. So we see it twice daily here. That's probably not what we want. Publix, that's definitely what we want. And so, it has what we want, but it's still a little bit messy. So we need to clean it up some. But if we were to look at all of the stores, we can see where they're located. And as you imagine, they kind of just follow the main arteries around Davidson County. In order to clean up the stores, I basically just filtered down to supermarkets. So if something was labeled in as a supermarket, I kept that. Otherwise, I got rid of it. And so after doing that filtering, we can see here that we have a bunch of grocery stores here up in the top of the data frame. But if we look a little bit further down, we can see a bunch of dollar stores. And so again, since that's not exactly what we're looking for, I wanted to remove those dollar stores from consideration. And so this code right here is basically removing anything where the word dollar is in the store name. And then just double checking a little bit more to make sure that there isn't anything else that I need to include. And in fact, there was something that was lost. Kroger, there's only one Kroger in the non-dollar supermarket. So I needed to take one more step to add Kroger's back to the list of supermarkets. And so that's what this last piece is doing here. So now all that work, we have our sources of fresh food. And if we apply our filtered data to our map, we can see we have far fewer, but it still follows generally the same spread of data points. And so now we have our sources of fresh food. We have the counties or the census tracts that have greater than 20% poverty. Now we just need to see which of the census tracts have greater than 33% that are outside of the reasonable distance to travel for getting grocery stores. So that's what we'll do here. And again, what I did was I created buffers around all of the stores. So basically a region, a circle around each point. And so what that would look like is shown here. These are just showing the 1 mile radiuses. I didn't show the 10-mile radiuses because it would just pretty much cover all of Davidson County. But you can see here around each of the stores, each of these points, the circle around that is a 1 mile radius. And so essentially what I want to see is for all of the census tracts that have, which ones are have at least 33% that are more than 1 mile away. How many are at least 33% that are not inside one of these circles? And so to do that, that's what this function is doing, basically saying across all of the areas that supermarkets cover combined, how much of a census tract is within that area. Again, calculating a proportion, and then applying this function to just a single census tract. We can see that this entire census tract is inside the area of coverage for grocery stores. But if we scale this up and apply it to all of the census tracts, we can see for each census tract which ones have more than 33% that are away outside of reasonable distance to travel for a source of fresh food. So the first thing is calculating the ratio of low food access. And so applying the function that we had created to calculate the proportion that's more than a mile away, or 10 miles for a rural census tract from a source of fresh food. And then this last one here is just looking at the different criteria that we've created. So checking to see if the ratio of low food access is greater than 33%, that first cutoff that we had made. And then the second cutoff is whether or not the tract has above 20% poverty. And so looking for yes on that, and then whether or not it's more than 33% low food access. And since those are our two criteria, those are the ones that would be possible food deserts. So if we run this, we can take a look at the first few rows and see we have one possible food desert here where in fact it is above 20% poverty, and the proportion of the census tract that's more than a mile away from a source of fresh food is greater than 33%. So this does check both the boxes, which is why it's marked as a possible food desert. And if we overlay this onto our map, we can see here which census tracts are possible food deserts in Davidson County. So we have a lot of North Nashville, a pocket in downtown, and then again down towards this southeast region of Davidson County. Based on the calculations that we took, these are, again, possible food deserts in Davidson County. We can add a little bit more context to our map using something called Folium. And if we put our possible food deserts over this map, we can see, again, with more context, where all of these possible food deserts are located. So again, I know I went pretty fast there at the end, but this honestly to me was a pretty surprising result, seeing not only where, and it kind of lined up once I understood where the food deserts were located, but seeing where and how many possible food deserts there are, even in places downtown, which you would expect there to be access to a lot of things down there, but maybe not as much access as you would expect. So I know I am going way over. Let me jump over back to the slides and talk a little bit about some possible food future directions. incorporating other indicators like public transportation that could change the picture of what residents have access to, and so it could shift around, hopefully reduce the number of possible food deserts, but that kind of incorporating other factors into the equation, casting a wider net, looking for other sources of fresh food. I know I mentioned farmers markets, but there's other sources of fresh food as well. And then kind of asking that initial question, are there certain store types that do contribute to food deserts? So look if there's a correlation between certain store types and food deserts in Davidson County. And that is all I have. So yeah, any questions? Sorry, Alex, for taking up 5-10 minutes of the.
No, you're good. You're only 5 minutes over. So I've got a couple queued up. Let's just kind of rapid fire through those. One is, are there any other APIs than Google that you kind of know of or looked into?
For looking for locations of stores, only the Google API is what I looked into. Other APIs that you could use, I don't know if I would use the Google API. It would be any kind of like map API. So I guess you could use, let's see, what's another GPS thing? Google's really the only game in town, or Waze, which is owned by Google.
That's
free. OpenStreet or whatever it is.
That's free. Yeah, good point. Say again, Justin.
OpenStreet.
OpenStreet, yeah, OpenStreet could work. Maybe not thinking about like mapping things, but there might be APIs that are for like restaurants or grocery stores or like food delivery things. Maybe that's something you can use. The thing that I kept running into was paywalls. So there are curated lists, but you have to pay to get the list. So most likely it would be some kind of web scraping that I would think you would have to do if you find a list posted somewhere, scraping that list. But yeah, Google Maps is the only thing that I looked at. Once I found something that worked, I kind of stopped looking.
Next question. So you already answered this, and but like if it's not a supermarket, like, or kind of like this, so like a turnip truck, would that count, or how does that classify?
Yeah, turnip truck I think would count as a source of fresh food. I don't know how Google is classifying it, and that's exactly kind of to this point up here, or this one right here. Just do a really thorough search, kind of like look at all the data, or at least a large handful of it, to see what things am I missing. It's a little bit of like domain knowledge. Like, yeah, I know that turnip truck in East Nashville, is that one on the list? Maybe not. And so that's absolutely the right thing to look for.
And this is a really good topic, and I think kind of touches on, or a good question. Daniel asked, what incentives would organizations have around opening stores in these food deserts, since it's often based on population and predicted profit?
Right. Yeah, that is an excellent question. And I mean, I'm not an economist, so I don't know, but I would imagine these companies, they're companies, they're looking for profit. And so putting a grocery store kind of in a central area that would accommodate some lower population areas may not be a good business move for them. I know just like down the street from me, there's like a Publix and a Kroger across the street. In terms of servicing a population or like giving sources of fresh food, why are they overlapping with each other? But that's a good place for them to put a grocery store. They found there are particular areas that have higher foot traffic. So yeah, I think this is a little bit of a tug of war in my mind. I don't know what incentives we could add to encourage putting grocery stores in a place that would help out food deserts.
And I would almost say, like, maybe not even limited to grocery stores, but maybe not full size, but maybe like smaller markets probably would need to have some sort of government subsidy that would help the overhead of managing a store. There's a lot of overhead, so if you don't have enough foot traffic, so there need to be some sort of government support.
Well, what were the,
that's a good idea.
at the beginning, Mahesh, you mentioned there were other factors too, such as like transportation, access to public transportation and those things. So maybe if it's not economically viable to move, let's say, commercial real estate into the area, it might be more economically viable to provide those other services, right?
Yeah, I would love expanded public transportation. That got voted down a couple of years ago. So
Meredith, you asked a good question. Do you want to talk a little bit about that?
Yeah, thanks for giving me the opportunity. I was just wondering if the correlation between Dollar General or other particular stores has been established between those kinds of stores and food deserts. And so it's just a matter of now whether there's a causal relationship. And if so, if I'm trying to figure out what even the mechanism would be of the causal relationship and how that could be parsed out.
yeah, it's definitely something that's been well studied, and I think they have found a correlation. The strength of the correlation or the nature of the correlation, I can't recall fully. It's also something that is an active area of research, so that's something like the USDA and other organizations are looking into to identify. My understanding is that it ends up being a little bit of competition. So food deserts care about sources of fresh food, but if you're looking to, pick something up for your family on the way home, you might just be looking for something, and like fresh or not, that's not something that you necessarily care about. And so Dollar General, because they can offer things for such a low price, they end up out competing or pricing out other sources of fresh food. So Kroger's and Publix, for example, they have more overhead dealing with fresh food. Dollar General doesn't have to deal with it. So I think it ends up being competition. And the picture that I showed at the beginning, that's from an article, I think it's a CBS News article, but it was interesting because this is a town in Iowa that, there's cornfields in Iowa always, and they are great producers of fresh food, but they themselves are a food desert. And so the irony there is just really hard to miss. I don't know fully, but I think it has a fair amount to do with competition. So yeah, but yeah, that causal relationship I think it's going to be hard to really nail down. That's a really good question, though. That's one thing that I really want to look into. I think it's a very interesting and pertinent question.
Awesome. Well, those are all the questions that I had. Does anyone else have any other questions? And I posted in chat, there's a local nonprofit that I've interacted with a few times, Second Harvest, Middle Tennessee. They're a really good nonprofit. If you're interested in kind of seeking out a local nonprofit looking to combat this issue. Awesome. Well, Mahesh, any closing comments?
Just apologize again for kind of speeding through there at the end. The exciting parts really are the geospatial things that happen a little bit later on. If you're interested in this, please feel free to reach out to me on LinkedIn, or send me an email or anything like that. Check out the GitHub repo and definitely that Kaggle kernel. That'll be a good way to kind of walk through and have a little bit more explanation along with that if you're interested in learning more. And thank you all for your attention. I really appreciate you for having me.
Awesome. Thank you, Mahesh. And everyone, just wrapping up, I will be working with Mahesh to kind of consolidate the links and everything that he talked about tonight. And I'll be sending that out in a follow-up message as well as I'll be getting this video posted to YouTube. Awesome. Thank you, everyone. Hope you have a good night.
Bye, everyone.